Good news everyone, I wanted to make a video on the physical and chemical properties of matter. I wanted to go over what the definition of them are, what a few examples of them are, how we can tell the difference between them, and also have a little look about chemical and physical changes. Right, so to start with, physical properties are something about a substance that can be measured or observed without changing that substance's chemical identity. Chemical properties are how the substance reacts in different chemical environments. So there's a lot to talk about here, as pretty much most chemicals can react with a lot of other chemicals. However, there are a few main ones that we'll be going over. So to start with, we'll be going through a few physical properties. So physical properties include things like a substance's color, what state of matter it currently is. So we're just going to put down state, and the state that it could be in, it could be a solid, a liquid, or a gas. Or we can also look to see what temperature that substance is. We can also look to see what temperature it melts at. This is called its melting point. We can also see at what temperature the substance boils at. This is called its boiling point. Other properties that we can measure about a physical substance include things like its hardness. We can also measure its density. Density is a measure of how much something weighs for the same volume. So for example, if I were to have this, say take this pot here, it is reasonably heavy. If you were to take any ceramic pot around your home, you'll find out that these things tend to be quite heavy. However, if this thing was made out of gold, it would be a lot heavier. Even though it's the same shape and the same size, a gold pot would weigh a lot more than the ceramic pot. Last but not least, an important physical property of a substance is how it conducts. This refers to both heat and also electricity. Now, chemical properties. A chemical property is how something reacts in different chemical environments. So these can include things like how flammable it is. Another chemical property is how corrosive something is. And how toxic it is to people and animals and plants. As chemicals can react with pretty much everything and anything, the list here is very short and is very general. However, I will just sum up chemical reactions with pretty much everything else as just reactivity. Cool. Now to address chemical and physical changes. So a physical change is where we change the physical properties of a substance. So this could be we change how hard it is, how dense it is, maybe change its color or its state. So we could melt ice and turn it into, say, a liquid. We could also then say boil that liquid and turn that liquid into a gas. These are all examples of state changes, and they are physical changes. They all depend on its temperature. When we're changing any of these properties here, we are not changing a substance's chemical identity. It is still the same chemical. It is still the same chemical. When we are boiling our water, From a liquid to a gas, it is still water. We're going from liquid water to gaseous water or water vapor. And when we are melting our solid water as ice into liquid water, in both states, our substance is still water. We are just changing its state. However, when we change a substance's chemical property through chemical change, we are changing its chemical identity. So we are fundamentally changing what it is. So in this example here, I have got two particles or two molecules of elemental hydrogen, and I am then reacting that with one molecule or one particle of elemental oxygen. What I am then creating after this is water. So I am fundamentally taking these reactants or these atoms here. So I am fundamentally taking these molecules here, I'm mixing them all up, swapping them all around, and I'm making something fundamentally different over here. So as you can see, I've broken up these little green balls over here. I've broken up the two red balls. I've mixed them around and I've stuck them together differently. So this object over here, this chemical right here, is fundamentally different to this chemical over here. This is hydrogen gas. This is water. I've taken two substances and I've chemically changed them into something completely different. This is what changing something's chemical identity is all about. Cool. So to summarize, the main difference between physical change and chemical change is that chemical change is easier to reverse. So think back to melting ice or boiling water. It's quite easy to reverse those changes, so I can freeze water to turn it back into ice, or I can condense back down water vapor to make it back into liquid water. However, with chemical changes, it is a little bit more difficult to reverse these reactions or to reverse these changes. Going back to our example here with hydrogen gas and oxygen gas, to make water, we have fundamentally rearranged how the atoms are attached to each other. This is a lot more difficult to reverse and generally only goes one way. So chemical changes are hard to reverse. So while physical changes are easy to reverse in principle, most chemical changes are very difficult to reverse. Yeah, Francis. Francis? Have you water, Francis? Bye, Francis.